Base learning objectives is that we know the properties of real numbers and can recognize them and give examples of them. So if you haven't already, there is a chart that goes with this that I've posted to Schoology, so you can print that and fill it out as we go along. Otherwise, you can write down the properties and the definitions and the examples as we go through it for an easy grade on Schoology. So let's go ahead. So our first property is the commutative property, and that's the property that states the order of the values does not matter. So I'm going to go ahead and I'm going to type it in so it goes in neatly that the order of those values does not matter. And some examples of that are that A plus B is the same as B plus A. Let me try and draw that in if it'll let me. A plus B. Let me try that again. I don't know why it doesn't want to let me write today. All right. A plus B is the same as B plus A. And an example with actual numbers are that we know 2 plus 3, which is 5, is the same as 3 plus, let me try that again so that it all fits on one little thing. I'm going to cut this in half so I can show you the examples for multiplication. So A plus B is the same as B plus A. We know 2 plus 3 is 5, but I also know that 3 plus 2 is 5. So it doesn't matter which one of those comes first. Adding them together is still going to give us the same answer. And that works as well with multiplication. The order of those multiplications do not matter either. So we could have A times B. We know two variables next to each other mean multiplication. So you could write AB, or you could write A times B is equal to B times A. Excuse me. And an example of that is that we know 3 times 5 is 15. But the same thing, 5 times 3 is still 15. No matter what order I put those in, the answer will be the same. So the commutative property, I would circle that, is about the order. It states that the order of those numbers does not matter. All right, so then your associative property is about the grouping. So the grouping of the values. So the grouping of the values does not matter. So what that states, and again it works for addition and multiplication, that A plus B plus C, because they're all being added together, I could change the two that are added together into the group. Because they're all addition, it's still going to give me the same answer. So A plus B plus C, we're not going to change the order, so we're still going to have A plus B plus C, except instead of A and B being together, we're going to make B and C together. So I didn't change the order. All I did was change the numbers that were grouped together. So A plus B plus C, but with A and B grouped together, it's going to be the same if I change the grouping to B plus C. So we know, let's say 6 plus 5 plus 4. So we'll make 6 and 5 our A and our B. And then again, 6 plus 5 plus 4. This time we're going to group 5 and 4. So our order of operation tells us that we do our groupings first. So 6 plus 5 is 11. And 11 plus 4 is 15. So let's try the other side and see if we're going to get the same thing. Well, we know 5 plus 4 is 9. And 9 plus 6 is still 15. So 11 plus 4 is 15. And then the 9 plus 6 is 15. So changing the grouping, even though we still had to do our parentheses first, because that's what our parentheses states, did not change the order. Let's see if that same thing works with our multiplication. So It still states that the order doesn't matter, so we're going to do the same thing, but with multiplication. So let's say I had 2 times 3 times 4, and 2 times 3 times 4, and I have to write this a little bit bigger because my pen isn't here, but it should all fit in your table. If not, there should be a little bit of room on the side of the paper. All right, so we have 2 times 3 times 4 with 2 and 3 grouped together, and then 2 times 3 times 4 with 3 and 4 grouped together. Our associative property states, well, we didn't change the order, we changed the groupings, that those two should still equal each other. So let's check. We know 2 times 3 is 6, and 6 times 4 is 24. So let's see if they're equal. Well, we know 3 times 4 is 12, and 2 times 12 is 24. So we see that that does not change. So the associative property and the commutative property are the two that I see mixed up the most. So the way I remember is that if you think about the associative property, you think about your groupings. So associative sounds a lot like association. So that's a big fancy word that talks about, like, if you think about the people you talk to, the people that you are friends with, you might have one big clique of 3, you and 2 other friends. There's 3 of you. Maybe one day you hang out with Sally, the other day you hang out with Jill, but you're all still one big group of friends. So changing that association does not change your group of friends. Commutative sounds like a lot like commute, which a lot of people commute is your drive to work. So my drive from Aiken to Jackson is about 25 minutes. But if I change the order, so if I change the order, so if, instead of going from Aiken to Jackson, I go Jackson to Aiken, it is still going to be the same 25 minutes. So the order of my commute to Aiken to Jackson or to Jackson to Aiken does not change. All right, so scroll down. Make sure you guys get this. Here's the associative property. Pause it if you need to. Here's that commutative property. Change it, pause it if you need to. Make sure you get that filled out. All right, so next is our identity property, and this again works for addition and multiplication. The identity property states that you're going to keep the same. So it stays, and I'll type it so it's neater. It stays the same. I'm going to put on our lines, it stays the same. So an example of that for addition is that if I add something 0 to something, so let's say a plus 0, anything plus 0 is going to be itself. So with real numbers, let's try we had 7 plus 0. I'm still going to get 7. The same works for multiplication, but times 1. So 1 times A is still going to give me 1. Or sorry, is still going to give me A. And if we wanted to plug in a real number, 1 times 8, I'm still going to get 8. So the identity property states that if I add 0 to something, it's going to stay what it is. If I multiply anything by 1, it's going to stay what it is. So the inverse property we talked a little bit about when we were learning about our integers. So it's using the opposite to cancel a value. So we talked about the inverse property. And I'm going to type it again, just because I feel like it's a little bit neater. All right, using the opposite. All right, back to my train of thought. So we talked about this when we were learning about integers. We said that the inverse property of addition stated that if I had -8 and +8 and I added them together, they would cancel out. So if I had 7 plus -7, we're going to get 0. So what it states was, and just to give you your letter form that I've been giving you, A plus -A is going to give me 0. So if you have a positive and a negative of the same number and you add them together, you're going to get 0. And this also works for multiplication, and that is that if I had whole number A times 1 over A, I am going to get 1. So see how in the first one we got 0 and the other one was 1? This will work when we get to equations, but how this works is, let me show you with numbers. So if I had 7 times 1 over 7, well, we know whole numbers, if we're multiplying fractions, can be put over 1. 7 times 1 is 7, and 7 times 1 is 7, and 7 over 7 simplifies to 1. So that's our inverse property. It states that a positive and a negative of the same number being added together cancel out to 0, and a whole number or times 1 of the same over the same number are going to give you, so in this case, in our number example, 7 over 1 times 1 over 7 equals 7 over 7, and 7 over 7 just simplifies to 1. So the opposite, A over 1, you flip A over 1, you're going to get 1 over A. So a fraction times its flipped fraction is going to give you 1. So like if I had 4 over 7 and 7 over 4, those are opposite because they're the same fraction, but flipped, we're going to get 28 over 28, which is simply 1. So the opposite, or the flipped fraction, is going to multiply out to give you 1. So that's your inverse property. Pause it if you need to fill that in. That's your identity property. Pause that if you need to fill that in. And here are our last two properties. Our property of 0. Property of 0, I think, is the easiest one. Multiplying by 0 always is going to give you 0. A times 0 equals 0. Your number, 7 times 0, still 0. And the distributive property, we started to talk about it. We're going to talk about it some more this week. I think we kind of struggled with it, so I want to spend some more time with it. The distributive property states sorry, I lost my train of thought. That if we multiply a value to an expression inside parentheses. So we learned this. If I have A parentheses B plus C is the same as A times B, the first term, plus A times C, the second term. So, and we've done this before, if I have 4 parentheses B plus 4, we know 4 times B, we're going to assume 1, so you could say 4 times 1, keep the B, 4B, and then 4 times 4 plus 16. And that is our distributive property. I'm going to give you a second. Pause this and write it down. Perfect. All right, make sure you have all of your notes. If you don't, go back. I gave you chances to pause them. I want you to go ahead and use your notes to determine each of these letters, and I know they're in different orders. I pulled some of them out. Each of these are only used once, and this is your word bank. These are all your properties. You should have your notes on your properties to figure out what each of these letters are. So I want you to go ahead and pause this and figure it out, and then we will go through it together. All right. So let's look at this. So on this first one, I have AB squared, and it doesn't matter what it is, times 0 equals 0. So which property states that something times 0 is going to give me 0? By now you should have already paused this. We're going through this, so check your answers. That's right, the zero property. All right, my next one, I have 7 plus 5 plus 1 is the same as 7 plus 5 plus 1. All we've done is changed the groupings. We did not change the order. Which one of those, if I could speak, which one of those talked about changing our groupings? Or our association? Change our friends that we're associating with? That's right. Our associative property is our grouping one. If you can remember grouping, you'll remember the associative property. All right, D says that 7 times x minus 3 is equal to 7x plus 21. What did we do from the first part to the second part? That's right. They distributed that 7 to show you that those two are equal. All right. Which one states that if I have a positive and a negative of the same number and I add them together, I'm going to get 0? My inverse property. This is our inverse of addition. All right, and then G, I have a plus b plus 0 is equal to 0 plus a plus b. You look, our groupings did not change, but the order of those numbers did. Which one talks about my order? That's right, your commute from your house to your school does not change. It's going to be the same amount of time, given there's no traffic or outside factors, to and from your house to school. All right, and my last one, I have 4x times 1 equals 4x. Which one of those do I have that tells me anything times 1 is itself? Identity, because identity is what you see yourself as. Perfect. All right, so our objective was that we knew the properties of real numbers and can recognize them and give examples of them. I think that we did a good job going through them, showing some examples. We worked through some practice problems, trying to figure out which properties were used. So if you feel comfortable with this, there's your assignment on this on Schoology. Otherwise, please, please, please come to our small group. All right, guys, have a great day.